Hey guys, welcome. Today, guys, we're going to be focusing on a new lesson, and this lesson has to do with functions. We talked a lot about, functions as in, writing a function and it being similar to an equation. But what exactly is a function? It's more than just a relationship. It's a special type of relationship, and we're going to talk about that. So a function, and our learning target today is, I know that a function has one, that's important, one output that's our y for every input, that's our x. So a function has exactly one output for every input, which you might be like, what's that mean? That's okay. We'll figure that out together, you and me together. What does that mean? A function has one and only one output for each input. So, function. It's a rule that assigns exactly how many? One output to every input. A function can be represented in several different ways. So we can represent functions in several different ways. One of the ways we can represent a function is in a graph, right? Just like we've written equations or functions from graphs with x and y axis. We can also represent a function using a table. We've done that. We've used tables to represent these. We can also do it as a relation of ordered pairs. So like ordered pairs is in x, y coordinates. And then we can also do it algebraically, using the equation with variables. So there's several ways we can represent functions, and we've done all these. We've done graphs, tables, relations, and we've done lots of equations. Okay, so there's lots of ways that we can show equations, functions. So we talked about inputs and outputs. I said there's exactly one input or one output for every input. So what are the inputs? The inputs are what we call the independent variables. We've talked a lot about what independent variables are. So what are the independent variables? Well, when we look at a graph, where does the independent variable go? Or when we look at an equation, where does the independent variable go? The inputs go on the x-axis. So inputs are the independent variable, like the time, or the months, or the thing that is known, or the thickness of the bridge. Okay, these are all the x-axis represented by an x. So the inputs are the independent variables, and it's often represented by an x on our graph or an x in our equation, mx, the input. So I always remember that as x is inside the equation. It's in the middle of our equation, right? And mx plus b. The other one, we have the output. So that's like what comes out, right? It's like a box. It's like a machine. This is a machine. It's creating these. We put something in, like we say, 2 layers of bridge. That bridge that was 2 layers. Then we get something out. It holds 16 pennies. Okay? So the outputs are the dependent, which are always on the y-axis. So we have lots of relationships that this works for. functions. But it's only true if there's only one, exactly one output for every input. And there are scenarios, we haven't really seen any this year yet, when there are more than one output for an input. And that's when not a function. Okay? So let's talk about when they are functions and when they are not functions. So this one says which relation represents a function. So these are all relations. Okay, relation of ordered pairs. This is represented as a relation of ordered pairs. And it's asking us which of these right here represents a function. So when we look through here, we know that we have exactly one output for each input. So we have an input of 0, we get an output of 3. We have an input of 2, we get an output of 4. But we have an input of 0, we get an output of 6. So see here, we have an input of 0, output of 3. We also have an input of 0 and an output of 6. This is not a function because you cannot, let me repeat, you cannot have a different output for the same input. We cannot have a different result, a different output. If we put 0 in, we can't get 3 out and 6 out. We can't get different things coming out. So that is not a function. -7 gives us a 5, -7 gives us a 1. That cannot be a function. Why? I'm waiting. Why? Hopefully you said because we cannot have the same input of -7 giving us different outputs, a 5 and a 1. Is this a function? 2 gives us a 0, 6 gives us a 2, and 6 gives us a -2. Is that a function? Of course not. Good job. Because we cannot have a 6 having an output of 2 and a 6 having an output of -2. You can't have the same input giving you different outputs. Well, hopefully this one is 6, -6 is 5, -3 is 2, 1 is 2, and 6 is 5. Are these all different? They are. -6, -3, 1, 6. So that is a function. Can the outputs be the same? Sure. But we cannot have the same input giving us a different output. So, if we look at the next example, we're going to talk about is this a function, or which one is not a function? So 1 is a 5, input of 1, output of 5. So we put 1 in, we get 5 out. That's check. We put 2 in, we get 6 out. Check, or 6 out, yeah. Check. We put 3 in, we get 6 out. Check. These can be the same, that's fine. We put 4 in, we get 7 out. Check. 1 gets us a 5, 2 gets us a 6, 3 gets us a 6, 4 gets us a 7. So, that's okay. 4 gives us a 7, 2 gets us a 1, -3 gets us a 6, and 3 gets us a 4. It's fine. It's good. -1 is a 6. 1 is a 3. 2 is a 5. 1 is a 7. That's no good. Why is that not a function? Well, because 1, an input of 1 cannot result of an output of 3 and also an output of 7. If I were to graph this, I would have 1, 3, and 1, 7. Those would be on the same vertical line. which is a no-no. Can't do that. You can't have the same input giving you the different output. So this one is not a function. That one is a function. So that's how we tell if something's a function, by looking at the ordered pairs. The way we tell if something is a function by comparing a graph is we basically look at it and we draw vertical lines through them. And if we draw a vertical line, we say, well, will this cross at 2 points on the vertical line? In this case, it hits at 2 separate points. So this is not a function. What that means is, why is it not a function? Well, it's not a function because this coordinate and this coordinate have the same x value. Let's estimate. Let's say that x value of this one is 3 and the y value is -2. This one would also be 3 and the y value is +2. So they have the same x value, the same input, but different outputs. One output for each input. You can only have one output. These have different outputs for the same input, the same x value. This one, not a function. It fails my vertical line test. It crosses here, here. You could do lots of vertical line tests, but every time it fails. Every time it hits at more than one spot, it fails. This one fails miserably. It hits all these spots. Again, it fails for the same reason. Fails the vertical line test. This one passes. So this one is not. This one is a function. Alright, if we look at this one, see if you can figure out on this example 4 which one represents the function. So which one could I draw a vertical line through and it only hits the line at one spot? It only hits my vertical line at one spot where it crosses my vertical line. Fail, 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 pass. So that is my function. It only hits it at one spot, no matter where I draw it. Only hits it at one spot. Hits it twice, hits it infinite number of times, hits it twice. We can test whether a graph is a function by using our vertical line test. Voila. I hope today you learned something about how we determine if a relation is a function. And a relation is a function if there's exactly one output for each input. Please work on your bronze problems. Work on your silver problems. And if you can work on your gold problem, that would be most excellent. Guys, proud of you each and every day. You guys are getting better at this stuff. You're getting more prepared for algebra, more prepared for high school. You're learning. You're just getting more prepared for life in general. My goal each and every day is to help you prepare yourselves for your future and what comes next. Hopefully you can see that. Hopefully you can see beyond just, this stuff. Let's see that what we do here each and every day matters, and you guys are improving little bit by little bit. Signing off today. So hope to see you soon, Mr. Urschel.